You know, we've all heard this idea in AI, right? That bigger models are always better. It feels like this constant race to scale. Everyone's building bigger and bigger AIs. But what if that race is maybe hitting a wall? Today, we're doing a deep dive into something really different, a kind of new blueprint for AI. One that's not about just knowing everything, but about, well, deep expertise, almost superhuman in a way.
Yeah, exactly. Our mission today is to really understand the limits of these current top-down ways of building AI. And then we'll explore this whole other bottom-up idea, how it uses what some are calling smart data to create, well, domain-specific superintelligence. It's a totally different way of thinking about it.
Okay, so let's unpack that top-down approach first. That's basically feeding the AI just vast amounts of data, like the whole internet, right? Trying to make a sort of digital jack-of-all-trades, something that knows a little bit about everything.
That's the idea, yeah. Aiming for breadth.
But here's where it gets really interesting. The costs are huge, aren't they? And the environmental impact, too. We're talking massive amounts of energy.
Absolutely. Huge costs. But maybe even more important is this other limitation, what researchers call the recall reasoning gap. Think about it like this. Imagine a student just skimming, say, 1,000 encyclopedias for a test.
Okay.
They might be able to recall a ton of isolated facts, right? But ask them to explain something deeply, to show causal understanding. Probably not, and that's what we see. Our sources show these big generalist models. They can recall medical facts, sure.
Yeah.
But solving complex, multi-step medical problems, their accuracy was dismally low.
Wow, dismally low.
Yeah. And this isn't just some small technical glitch. It feels more like a strategic dead end for that whole approach.
That encyclopedia analogy really makes sense. Just knowing facts isn't the same as understanding. So if that's the dead end, what's the alternative? What does this all mean?
It means we need this new bottom-up philosophy.
Yeah.
So instead of that student skimming encyclopedias, imagine a different student, one who diligently works through a proper curriculum, starts with the basics, the axioms, masters them, and then builds up more complex knowledge, step by step.
Right, building a solid foundation.
Exactly. And the goal here isn't a jack of all trades. It's domain-specific superintelligence. An AI that doesn't just match human experts in, say, one specific area of medicine, but vastly outperforms them. And this changes everything about data, too. It's not just big data anymore. It's about smarter data, structured data. Yeah. Quality and organization become key.
Okay, smarter data. And you mentioned an enabling technology for this. Knowledge graphs, KGs.
That's right, knowledge graphs. And what's fascinating here is how they work. It's actually pretty intuitive. You have nodes. These are just things, entities, like a spirin or myocardial infarction.
Okay.
And then you have edges. These are the relationships between them, like may treat. So you get these little facts, these triples, like aspirin may treat myocardial infarction.
These simple facts.
Exactly. But the real power comes when you chain these triples together into what are called multi-hop paths. So you could link diabetes mellitus, predisposes to kidney disease, with another fact, like kidney disease causes anemia. Now, the AI can trace that complex pathway.
Ah, I see. It's like connecting the dots.
Precisely. And in medicine, there's a kind of gold standard example called UMLS, the Unified Medical Language System. It's this huge structured map of medical concepts and how they relate, a foundational KG.
So it's not just data. It's data with relationships, structured knowledge. Okay, so how do you actually teach the AI using this? You mentioned an automated tutor.
Yeah, it's quite clever. It uses a task generation pipeline.
Yeah.
Sounds technical, but the idea is straightforward. First, path traversal. The AI basically explores the connections in the knowledge graph, like a detective following clues, learning the pathways.
Okay, exploring the map.
Then question-answer generation.
Yeah.
This step automatically turns those paths it found into questions, often really realistic natural language questions, like complex clinical cases,
So it generates its own test questions from the KG.
Exactly. And then finally, there's curriculum curation. This just makes sure the AI gets a good mix of questions, different types, different complexities, a proper education, not just rote learning.
And the real breakthrough, the thing that makes this so different, is something called thinking traces.
Ah, yes. This is the true secret sauce, I think. With every answer, the AI doesn't just give the solution. It learns a detailed, step-by-step reason for it, directly from the knowledge graph pathways it used.
So you can see its work.
Precisely. It completely breaks open the AI black box. Instead, you get glass box systems. You can see exactly how the AI reached its conclusion. Imagine a doctor using this. They can review the AI's reasoning step by step, check its work, trust it, collaborate with it. That's fundamentally different from the opaque systems we mostly have now. It makes them trustworthy, explainable, and ultimately much safer.
That transparency. Wow, that really is game-changing. Okay, so the big question, how did this approach actually perform? The graduation exam, so to speak.
Right, the results. Well, they took a model called QWQ-Med3. And importantly, it was a moderately sized model, only 32 billion parameters. That's actually significantly smaller than many of these giant generalist models out there.
Smaller, okay.
And it was tested on this really tough benchmark, ICD bench, which is all about complex clinical diagnosis. QWQ-Med3 significantly outperformed much larger systems. We're talking state-of-the-art proprietary models like Gemini 2.5 Pro, O3. It did much better.
Wow.
Yeah. And crucially, it kept performing well, even on the really hard problems.
Wow.
The complex reasoning tasks. Those were exactly the places where the bigger generalist models tended to fail.
Yeah.
So this really throws a wrench in that whole scaling is all you need idea that's been so dominant.
It really does. And this leads to something else important, right? This strategic horizon idea, the green AI aspect.
Absolutely. If you can get better performance with smaller models, well, that means lower training costs, lower energy use during operations, a huge environmental benefit. It makes powerful AI much more sustainable and accessible.
Which is critical if this tech is going to be widespread.
Definitely. And if we zoom out, look at the bigger picture. This points towards a different vision for artificial general intelligence, for AGI. Maybe AGI isn't one single giant superbrain. Maybe it's more like a society of minds, an ecosystem, Lots of these highly specialized superintelligences, each expert in its own domain, but collaborating on the really complex world-scale problems.
A society of AI minds.
Yeah. And that raises a really interesting question for you listening.
Yeah.
The next big challenge, the complex frontier. Maybe it's not just building bigger models. Maybe it's about systems integration, organizational design. How do you build this artificial economy of knowledge and expertise?
An artificial economy of knowledge, that really is something to think about. And it makes you wonder what new kinds of jobs or skills might emerge. Like maybe we'll need knowledge cartographers, people whose whole job is translating human expertise into these structured knowledge graphs for the AIs to learn from. Something for you to chew on.